Hey everybody, this is Larry. This is me going over Q4 of the weekly contest for 5 construct string with minimum cost. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one is an 8-pointer and it took me about 15 minutes, but to be honest, well, I mean, I guess it's one of those things, right? If you know the answer, of course, it's much easier. But this is not a difficult problem in concept, but the biggest thing is that it is an analysis in complexity and constraints, right? So the thing is that this is going target length is n, right? Yeah. So this is n, this, or maybe t, and this is n is the number of words, and each number of them is big, but the total sum of the length of the word has a 5 times 10 to the 4th constraint. So the first thing, or the first couple of things that I was trying to get through, to be honest, is just trying to do some sort of, so the idea that I had immediately was dynamic programming. This is a very, it gives itself to a very natural, shortest path in a DAG, right? So that's a dynamic programming idea. You can think about it as that in the target, for example, ABC, meaning that ABC, there's an edge from the beginning of A to the end of C. D is, before D and after D and so forth. I mean, for this particular video, I'm not going to get into that too much because, just to be frank, this is an 8-pointer. If you have issues with that problem, you should work it out. I mean, that is a prerequisite for this problem. You should have that understanding, and I think it is definitely a Leetcode problem with easier constraints. Maybe n is like 1,000 or 2,000 or something on Leetcode, and you should be able to solve that, right? But in this case, n is too big, right? So the way that I think about it is that if we have the shortest path in the DAG, it's going to be too slow because it's going to be n squared, and this is 5 times 10 to the 4th, n squared is going to be too slow. And that really basically, maybe I need to look back at the tapes just to kind of see how long I end up taking, but I just spent a long time basically on that idea of trying to figure out how to get out of n squared, because n squared is going to be too slow. I did, even in the beginning, I did think about this idea of having a try, but I didn't really get anywhere with it because I still thought that it would be n squared or n times t, because if in the worst case, you can imagine, and we'll prove that in a sec, but you can imagine that in the worst case, for each beginning of the character, you can draw n square edges, right? So let me actually draw it out right now. Maybe that's a little bit cleaner to understand. So basically, just to reiterate, for example, you have a target word that is like right? And basically you have the nodes are between the characters, and you're trying to basically get from here to here in the shortest costs. And of course the edges are if the things that are in what I call the dictionary, right? So for example, if there's ABC, this is ABC, right? And a cost of maybe 100 or something like this. This is cost of 1. Maybe this has a cost of 5 or whatever, right? And so you have all these edges. So, right? So my worry was that in a worst case scenario, you have A, B, C, whatever. Okay, just this, right? My worst case scenario was that thinking that there could be an edge, that, a way to construct it such that it looks like this, right? So basically every possible edges, and of course I'm not gonna finish writing all these out, but let's say they're also length 3, right? And so if you add up all the edges, this is just n square edges, right? So yeah, so that's basically the idea that I just couldn't figure out a long time how to get out of it. And it turns out that the tricky thing, the key observation for this problem is this total sum word sub I of length is less than or equal to 5 times 10 to the fourth, right? Because then now, even though there are a lot of different words, this makes it so that it is basically speaking not possible to have the worst case. So what is a way to get a worst case, right? I mean, there's this, but even a very clean observation is that you just run out of edges because there's only 5 times 10 to the fourth number of edges, words. So then, there's no way to kind of construct this per se, but there is another way to do it, right? A easy way to construct a really bad case is if all of them are the same characters. So you have A, dot, 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 let's say there's, the max case number of them. And then now you want to draw edges like this. How do you do it, right? 2, length 3, length 4, all the possible lengths, right? So the way that this happens is that you can, if in the dictionary, you have an A, you have an AA, you have an AAA, you have an AAAA, dot, 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 right? So then now, if we have 5 times 10 to the fourth of this, then now this would create a complete graph where it's going to be 5 times 10 to the fourth square, right? Which is too big. I mean, you could do the math, but it's like, it's too big, right? But, so the key observation that took me a while to kind of trust, to be honest, is that, like I said, there is this additional constraint that I have highlighted still, the total sum of length, right? So then now let's look back here. So the thing is that with this, what is the total sum of length? So right? It turns out the total sum of length of this thing is going to be 1, 2, 3, 4, 5, dot, 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 right? But what is this dot, dot, dot to? What is this K such that this is whatever, right? So it turns out, this is 50,000. So max K is going to be equal to, roughly speaking, square root of 50,000, because basically the sum of the K having K elements is just equal to 1 plus 2 plus 3 plus dot 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 plus K, which is equal to, I always mess this up, so forgive me if I have it wrong. I always forget if it's plus 1 or minus 1. But either way, the point is that this is, roughly speaking, K squared, right? So I always mess this up, so if I'm wrong, let me know in the comments. But yeah, so this is K squared, so that means that, and K squared has to be less than 50,000. So that means that K is less than square root of 50,000, right? And what is that? I forgot. Let me, it's me getting our calculator that you can see. It's about 223, right? So K, K is less than about 223. And that's basically, that is very ugly, 223. And that's basically the answer, right? So then now we know that in the worst case, there can only be 223 of these. As long as we dedupe and stuff like that, we're fine. And so then now this is going to be this K times N and this is the case in which the example that I have where it's all A's, then now for each node, you move 223 times. So then this is going to be O of K times N. And that's basically the idea and K times that is going to be about 10 million, which is still a little bit sketched, to be honest. Let me actually double check with my, how the timing goes. Actually, a little bit slow, to be honest. Maybe we need to just do some optimizing. But yeah, but that's basically the idea. And I have but that said, you still have to be very smart about it. And the way that I did it is with a try. The reason I did it with a try is so that I don't have to compare each word, and so that I could save progress on overlapping things. And so that we can terminate early. So all these three things allow us to is what I properties that I like about these things. But yeah. But yeah. Okay, so yeah, so that's basically the idea. So let's go through it, right? So first of all, I call this the dictionary. So for each dictionary word, I just create, I just put everything in a try. The reason why I usually, if you follow me along, if you follow me along, then you know that I like using like more classes as an abstraction, but I did want it to kind of just make a little bit of optimization, just because it's because I don't know, Leetcode is slow and it is a little bit freaking me out. But yeah, so for each word, I basically iterate through the try to add it. This is adding the word to the try, and then I add the cost to it, and I minimize this. This function actually cost me a wrong answer because I was silly about dedupes. I was thinking about it during the contest, but I just forgot about it as I was implementing. And then yeah, the duplicate words in the dictionary, which is it is what it is. But yeah, and then after that, so now we have the try setup. We just have dynamic programming, and yeah, like I said, this is going to be shortest path in a shortest path in a DAG. So for J, so basically we just, for each iteration, we just go to see how far we can get. Number of, how far to go for edges. This is kind of pricey still, to be honest, but yeah. And then here's the DP part, where we just kind of update the cost of the DP as we go ahead. Yeah. And then at the end, we just return the biggest thing. And that's pretty much it, ideally. Huh. I think yeah. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live during the contest now. Yeah, if you're watching this, this is me realizing that in the other video, I forgot to move the thing away. So let's go over the code real quick. Like I said, so this is just, yeah, this is just adding things to a try. This is dynamic programming, and this is going over the for each one, we just keep going. However, I have a couple of variations on this. So this as is, even though this is accepted, it is still going to be n squared in the worst case, because there is a case, because we still traverse the tree, even though some nodes are not possible. Because, for example, if you have, as we said, the worst case is going to be, let's say, a lot of A's. And if you have just one edge with a lot of A's, if we are at the second A, we cannot use this edge anyway. So that is one of my worst cases, is stuff like this. So I actually rewrote this variation. So the way that I have this is n squared, though it gets accepted for some reason. But I actually do have a not cleaner, but just a thing that cleans it up. And you can kind of see me doing it a couple of ways. Is it this one? Nope. Because I was trying to figure it out. But yeah, so I have additional code that basically just times things out from the try. So no, this one doesn't have it either, actually. What is wrong with code? Yeah, so basically, this is the variation that I have that fixes that complexity, because then now I time things out. So basically, for words that are too long, I pop them off the try, right? Yeah, for 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 words that are too long, I just pop them off the try, and that's pretty much it, really. Yeah, and this makes everything go faster in the worst case, but overall it's still not that much faster, so I don't know what to do with it. I also even have a dedupe here. So yeah. So going back to my first answer, I don't know. So I don't know what to tell you about this, because the reason is because I don't terminate early on here, because as I said, there are impossible edges. But once you get rid of that, it should handle better. But I don't know what this problem is. I don't know what the intended problem solution is. So I might very much, it may very much fail or something. So I don't know. But yeah, that is all I have for this one though. So let me know what you think. Thanks for watching. And yeah, you could watch my half attempt to solve this, the next portion, and then you could skip forward to when I solve it during the contest, I suppose. So yeah. So this is a bonus section. I think mine times out actually, and I also just realized afterwards that I forgot to move the thing. So, but this is the code. This is a weird video. I have to optimize this because there's this case where if there's all A's, this really times out, I think. I just spotted this, so I have to kind of try to optimize this out. So yeah. So give me a second. So this is like a bonus additional live footage, except for it comes before the thing. And then I'll go explain it in a little bit. Yeah. We want a max heap for length. Oh, no, we don't need a heap. We just need right. Word cost. So we want this to be okay. Right. And then here we want to basically what I'm wanting to do is time things out so that I don't keep on going. Right now I think mine times out in the worst case, which I'll go over in a little bit at some point. Okay, so then now is greater than n minus I. So then now we want something like for C in Word. We want to subtract this. What? And then now we can say or can address a target J dot count 0, we break. Okay. That's not quite what I want. Removing. Oh, that's because this word doesn't make sense. Okay, maybe now it's okay. Now it looks good. Okay. Let's YOLO submit just because we already got the right answer anyway. It may, I mean, this does stuff, but it may slow it down. So I don't know. We'll see if this is good enough. Okay, but I'll explain in a sec. So, well, this is actually even slower, so that's worse. But because basically the worst case that I had was okay. Well, that's a really weird one, though. Like, I think this is the worst case for me. So I do optimize for this one very quickly. Now that with this now, but it overall is slower, so I don't know what to make of it, to be honest. Can I do a little bit better? I don't know why this is so slow though. I would have thought this is faster. Or at least it makes this loop terminates earlier. But maybe not. Well, I guess one thing is that words needs to be deduped. So maybe we can do like I think that that's maybe one of the cases because I'm doing this too much, and also maybe this. But so we can do something like this. Maybe that helps. Basically, we're deduping a little bit and hoping that maybe that helps with this thing. It's hard to tell. I don't know what the right answer is, to be honest, now that I'm thinking about it. It may be that my code is just very well. Yeah, it's still 12 seconds, so that's not great either, to be honest. I don't get it. I don't know that this is intended. This is n square. That's what I'm trying to figure out. I mean, I did the deduping, I did the things. I don't know what else to do. It was the same idea. I mean, if we remove this, is it that much faster? It shouldn't change anything, but... I mean, the worst case is faster, but I guess the worst case is just not in it. But that means that someone's gonna put it in, so I don't know. Yeah, without the... well, now I'm doing a lot of funky stuff here, I guess that's why. I mean, without knowing what the max runtime is, it's kind of hard to figure out what to do with this one, because this is n square, and I think that's the part that I'm not quite sure. Yeah. Yeah, I don't know. Anyway, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live during the contest now. Now. That 5-minute penalty is gonna make it very tough for me to get a good rating, but it is what it is. Alright, I don't even know why I wait. Okay, give me a string target and array of string words. Literal cost, both array of length, same length. 4 people got this already. Imagine? Just tell us to start. Don't tell us to imagine. Okay, anyway, focus. Okay, you choose a word, append word supply to X, the cost is cost supply. Return the minimum to, okay, so you want to make this, okay. And the thing is going to be constraints, right? I mean, otherwise it's just straightforward DP, or shortest path rather. There are a lot of words. How many points is this? 8 pointer? 8 pointer, 4 people got it already? That is actually nuts. And maybe that will give me some time to catch up. Oh, wait, the total. Okay, so this changes things. 5 times 10 to the 4th times 2 is too big though, even if they have 1 character each. Is it a try? Create a try of the words. I mean, the thing is that, like, it may be that in Python this is good enough. No, that's not true, because you may loop through all the words and there'll still be timeout. You don't have time to match. How am I choking? Yeah, that. Okay. And this is straightforward. It's just about the complexity. I'm trying to figure it out. How are people getting it? Shortest path. Can I do shortest path? No, this is n square nodes, right? Or n square edges, maybe. Problem is you have to take a long time to construct it. I don't know how we make that fast enough to even just compare everything to everything out of here. Some word total, I mean, that's fine, but length can be pretty big. hope he was getting it. I'm not. I'm just not seeing the idea. Maybe it's Google, but who knows anymore. But n square. But that's how do you even do it faster than n square? Is it true though, Larry? Is it actually n square? There's only 26 of length 1. So, okay, so what is that? 1 plus 2 plus 3 plus 4. So then to square root. Okay, I guess so. Okay, fine. Then let's just do it with a try. I guess so. I'm worried about the timing, that's why I'm kind of doing it in line. I guess try was always the way to go, I don't know. Yeah, whatever, that's good enough. And cos is equal to it. What am I doing with C? What? Okay, yeah, fine. I think this makes sense, but I guess I don't need to count. It's implicit, right? with targets. I don't like this. Maybe off by 1. Oh, right. Super not confident. Let's take a look. 1, 2, and 7. Just off by 1s, really. Yeah, but okay, fine. It may time out, but honestly I'm not sure. Maybe it times out. Oh, wrong answer is even worse. That means that I've been sloppy. Oh, I actually knew this one. I was thinking about this, but I wasn't sure that it would come up. I thought about that input, but then I just forgot about it because I was thinking about deduping and I was looking for duplications. But yeah, okay. That was a very sad 5 minutes as well. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.